We're not dividing. Square rooting.
I know that. I'm just saying that.
Okay, so, right, but I do care, but what I'm trying to tell you is that it's not about division. It's not division. Square rooting is not dividing. Okay, and I'm telling you, think about it differently. Think about it in terms of square roots. Okay, so this first rule, what was your conclusion? Brianna? Say it again. All right, square root of A times square root of B. And this is what should help you. Down below, if you look at column 1. Yeah, in that second set of patterns, look at column 1. Here, the multiplication sign is implied. Yeah, if we write root A, root B, it's implied that we're multiplying. And if you look at that column below, what did you notice? No, what did you notice? Hopefully you all noticed the same thing. They equal each other. They're the same. Yeah? Hopefully you all saw that. And now, how can you explain this result? I'm telling you guys to look at column 1. Roman and Alex have both been trying to explain it with column 2. Look at column 1 and look at this rule. How can you use this rule in conjunction with column 1 to explain it? What is 18? If I rewrite 18 as a product, how can I write it? 9 times 2. And based on the rule from above, root 9 times 2 is the same as what? Root 9, root 2. What is the square root of 9? 3. That's why 3 root 2 is the same as root 18. Mm-hmm. Right, the square root of 2 is the square root of 2. That's why it stays square root of 2. Because there is no square root of 2, you're right. Exactly. And that's why we could have written that 18 is 6 times 3, but that wouldn't help us any, because neither 6 nor 3 have a square root. So that one that's root 300, I could write 150 times 2, but that doesn't help me. What helps me? 100 times 3. What is the square root of 100? What's the square root of 3? Well, it is something, but it's irrational. Yeah, remember back to Unit 1 where we talked about irrational numbers? We can't write this as a fraction. We can't write it as an exact decimal. This is the only way to write it exactly. So if I'm simplifying a radical, also known as a surd, so radical equals surd. Those are all the same words, equals anything under a root sign. Are there any more in the column that you need me to help explain? Or can you produce all the results? Yeah, Julia. Mm-hmm. Yep. Yep. Right, but 125 is what? Right. So that becomes 5 root 5. Yeah?
Basically, you try to find the numbers that multiply to get that number,
Exactly. Exactly. So for the people in the video, what they just said is that we're factoring and we're looking for factors that are perfect squares. All right, so 50. Are 10 or 5 a perfect square? 25 times 2. 5 root 2. 300. 10 root 3, that's on the other side. 48. So 48, you might come up with multiple answers. Okay, so one answer that you might come up with is 4 and 12, which is 2 root 12, but then 12 is also what? So this is the same as 2 times root 4 times root 3. So root 4 is 2. This does not become 22, it's 2 times 2. So the final simplified answer is 4 root 3. That means from the beginning, 48 is the same as what times 3? So from the beginning, it could have been root 16 root 3, which is also 4 root 3. Right, and square root of 4 is? So 2 times 2? Because 12 can't, so if we're simplifying, we need to simplify fully. Yeah? It's just like factoring. You look at it and you say, can it still factor? Does it still have perfect square, non-perfect square? What about 52? Eight and? Are we ready to listen to Andy? 4 and 13. Don't be afraid to start with 2. 52 is even, so I can divide it by 2 to help me think about my factors. 52 divided by 2 is 26, also even, which definitely means it divides by 4. So 2 root 13, I know 13 is a prime number, for sure it's not a perfect square. No? Keep going. Yeah, we're on the other side. Okay, the problem with this video is that I can't pause it. Just have to make 2 videos.